Our next topic is amines, and this is the last of all the functional groups in oxyorganic compound section. And this is not an oxyorganic compound because there's no oxygen in it. We've replaced it with the less electronegative nitrogen. So while all the things we've learned about oxyorganics is basically true for this, there's a couple of variations. One, the fact that nitrogen is less electronegative, which means the boiling points and freezing points will be slightly off from the others, and the vapor pressures will be slightly off. The other thing that's different is the fact that we have three types of amines. And that is based upon the number of alkyl groups that are bonding directly to the nitrogen. In this case, we have what we call a primary amine, written as 1 degree, but it's spoken as primary. In this case, we have one amine group, or one alkyl group bonding to the nitrogen. And the nitrogen, the hydrogen, or just the nitrogen itself, without any oxygens on it, is by definition an amine. But like I said, there's three types: the primary, the secondary, where we have two alkyl groups, which means that it loses a hydrogen that it had over here. So there's only one hydrogen here bonding to the nitrogen. And then the last type is the tertiary, which we write as 3 degree amine, but it's, like I said, pronounced as tertiary amine. And you have three alkyl groups, and there's no hydrogens bonding to the nitrogen, and you can imagine the changes in physical properties when that occurs, but we'll get back to that later, because I want to deal with nomenclature once I've introduced these. Now, the naming system for amines is rather similar to the naming system for ketones and for ethers, in that in the common naming system, we identify all the parts bonding to the functional group, which is the NH3. So the common name for this is a methyl group bonding to the amine group, so this is methylamine. And again, that's two words. The IUPAC name, again, very consistent, which is why I love the IUPAC system, is based upon the longest continuous chain of carbons, not nitrogen, just carbons in there. And that, in this case, is 1, so this is technically a methane. And we do what we've done with some of the others. You write down methane, but you don't put down the E, you drop it, and replace it with the word amine. So this is methanamine. Okay? So this over here, this is a primary amine because this carbon here bonds to the nitrogen, this one does not, this bonds to the carbon. So again, we only have one carbon bonding to the nitrogen. This is an ethane, so that becomes ethanamine. Dropping the E in ethane and putting amine in there. We have an ethyl group bonding to the amine for the common naming system, so this is called ethylamine. So these two names are very similar. These kind of go bad at this point. So at least for the common names, and not for the IUPAC is so consistent. Even though you don't like the oxys on ethers, it is consistent in how it names things. You can visualize what it looks like based upon the name they give it in the IUPAC, which is the beauty of the system. In this case here, you would normally, if this had been like an OH group, like an alcohol, you'd say 1-propanol. Do the same thing here. This is a nitrogen is bonded on the first of 3 carbons. It could go over here, which we'll talk about in just a little bit. But this, we have to give a number on because there's 2 different places where it can attach. So this is 1, and this is a propane. Drop the E and put amine. So this is 1-propanamine. Okay? This, when you have 3 carbons in a row and the attachment is on the end, and the amine group is considered an attachment in the common naming system. So we just call it propylamine for that, just like we did for the other 2. And again, 2 words. Okay, Methylmethane, that's nice, okay? That's supposed to be methylamine. I apologize. Methylamine, 2 words, methylamine. Okay, here we go. Moving on here. Now, this is an isomer of the propylamine we had over here. We moved the NH2 group over here. So it's like if we had an OH group there, we wouldn't call that propanol, we would call that 2-propanol. So the fact that we have this here makes that a 2-propanamine. And if we have the alcohol here, that alcohol will be named isopropyl alcohol. So this is going to be called isopropylamine. Okay, and then we come over to this ugly spot here. This is still considered a 2-propanamine because the longest continuous chain of carbons is 3, and this is bonded on the second carbon. So that is a 2-propanamine like this is over here, but you have a methyl group on the second carbon. So we put 2-methyl hyphen 2-propanamine. And I think the more times you use the IUPA system, the easier it becomes. And I hope that's the case for this. Just consider yourself you're lucky you're not being tested on this year like they will be next year. That'll be fun. All right, common naming system. Well, if you put an OH right there, that's tert-butyl alcohol. So this is called tert-butylamine. So that's how the secondary works. I'm sorry, that's primary in different places. Now, let's take a look at the secondary. Secondary means that the nitrogen is bonded to 2 different carbons. Now, this is where things get a little bit different, okay? The longest continuous chain of carbons here is only 1 because each carbon is separated by a nitrogen. So this is a methanamine. But we have a methyl group attached to the nitrogen. Now, since it's not attached to the carbon, we can't put a number on it. So we have to use the capital N as the insignia for where it is attached in methanamine. So this is N hyphen methyl methanamine. N hyphen methyl, oh man, me and the letter H today. I've just not been doing too well with the letter H. Let's get that methanamine. Methanamine, there we go. Common name, well, this is your functional group right here, your amine group, and what we have attached to it are 2 different methyl groups. So this is known as dimethylamine. Not too bad for the common naming system. Come over here, again, we have 2 alkyl groups bonded to the nitrogen, hence the name secondary amine. And so, according to IUPAC, the base name has to be the longest continuous chain of carbons. That'll be that 2-carbon chain, so this is going to end with ethanamine with a methyl group attached to the nitrogen. So this is N hyphen methyl ethanamine. Beauty and simplicity. Even though it doesn't look simple, you understand what the words mean, it is really nice. Now the common name again, you put your hand there and you see the 2 groups bonding to it. You got a methyl group and an ethyl group. Go alphabetical, ethyl before methyl. Ethyl, methyl, amine. 3 different words. 1 word for the IUPAC, 3 for the common. And finally, for this thing, I have 2 3-carbon groups bonding to it. So the longest continuous chain of carbons here is 3. I'll say it's this one right here, just to be consistent with the other 2, doesn't have to be. That is a propanamine group. But the amine group is found on carbon number 2. So that is a 2-propanamine. All right, so this is going to end with 2-propanamine. Over here, I have a 3-carbon chain bonding on the nitrogen. So this is N hyphen. But since the second carbon is bonding to the nitrogen, we have to put in parentheses what this group is doing as an attachment to the nitrogen. So put parentheses, 2-propyl, close parentheses, hyphen. So N, 2-propyl, 2-propanamine. Now the common naming system, you put your hand over here, go, oh, I got a couple of isopropyl groups. 2 of them use the prefix di. So this is di, isopropyl, amine. 2 words. Okay?